Alright, so we want to find out the total number of vehicles that we're selling. So the mean of the cars is 0 times 0.3 plus 1 times 0.4 plus 2 times 0.2 plus 3 times 0.1, which turns out to be 1.1. And then we go ahead and we do the mean of the SUVs, and we got 0 times 0.4 plus 1 times 0.5 plus 2 times 0.1, which means on average Window will sell 0.7 SUVs in a given day, which totals up to be 1.8 vehicles. And so when we have two separate independent, we're going to make sure that everything today is considered independent. We have a total of 1.8 cars. So the question is, how do we do the standard deviation, which is a little bit trickier than the mean. So the standard deviation for the cars is going to be 0 minus 1.1 squared times 0.3, and we're going to square root at the end of all this, plus 3 minus 1.1 squared times 0.1, which gives me a standard deviation of 0.89 for the cars. And we're going to do the same thing for the standard deviation of the SUVs. The square root of 0 minus 0.7 squared times 0.4 plus plus 2 minus 0.7 squared times 0.1. I forgot to square root this 0.89 up here, which is 0.94. And this equaled the square root of 0.41, which is 0.64. Now when I do this particular problem, where I'm doing the standard deviation of the total, I cannot just add these together because these are roots. And we cannot add together roots. So what I have to do is I have to square them first, and then take the square root of the total. So 0.89 squared plus 0.41 squared, square root. So this is 0.98. So she can be expect to be off by about 0.98 vehicles, almost one vehicle per day. And so you can think about that like the Pythagorean theorem when dealing with standard deviation of two different independent random variables. So what is the mean of standard deviation for 5 consecutive days, assuming once again we're always talking about these things being independent, because we are going to assume independence for all of these, or else these equations don't work. So if I wanted to find the mean for the week, I would add 1.8 plus 1.8, and you get it. It's 1.8 plus 1.8. So you could have just done 1.8 times 5 to get your answer of 9. Now for the standard deviation for the week, it is not 0.98 times 5 because we are talking about 5 different days. So this is going to be 0.98 squared plus 0.98 squared plus 0.98 squared plus 0.98 squared plus 0.98 squared, don't want to miss the last one, or the square root of 5 times 0.98 squared. And so on a weekly basis, she can be off by 2.19 cars approximately. If Linda makes $500 plus $100 per vehicle, how much can she expect to make in one day? Well, it was 1.8 and Sigma was 9.98. So if we make $500 plus $100 a day, the mean of her paycheck is 1.8 times $100 per vehicle plus the $500 she gets no matter what, which is $680. And the standard deviation of her paycheck per day is 0.98 times 100. The plus 5 doesn't matter, so the standard deviation in her paycheck is $98. The last one goes back to the cars, the original one. So the mean of the cars was 1.1. The mean of the SUVs was 0.7. The standard deviation of the SUVs was 0.64. The standard deviation for the cars was 0.94. And so if Linda makes $300 per car and $500 per SUV for this paycheck, so I'm going to call this X because I'm running out of letters. So we got 1.1 times 300 plus 0.7 times 500, which gives her a total of $680. And if we want the standard deviation of X, I would have to do 0.94 times 300, but that would be the standard deviation, so I need to square that, plus 0.64 times 500, but that's the standard deviation, so I would need to square that, and then I would need the square root. So her paycheck could be off by approximately $426.52 a day. So when you have sums and differences of independent random variables, for the means, the mean of X plus Y is pretty simple. You got the mean of X plus the mean of Y. Same thing for minus. Mean of X minus Y is the mean of X minus the mean of Y. The standard deviation of X plus Y is the standard deviation squared of X plus the variance of Y, and you square root it. And the standard deviation of X minus Y, you're still adding, because the more things that you have, the higher the standard deviation is going to go. So we always add the standard deviation. Alright, so let's do example number 2. Let's say, alright, so in problem number 2, you get $0.999 out of 1,000 times, and you get $500 1 out of 1,000 times. So 500 times 1 over 1,000 gives me the mean, which is 50 cents. So every time I play this game, I should get back 50 cents. Probably cost some money to play it, but we're not going to worry about that right now. And then the standard deviation is 0 minus 0.50 squared times 0.999 plus 500 minus 0.50 squared times 0.001, and then we're going to square root that, which gives me a standard deviation of 15.80. So that's just for one game. So if we're going to play 500 games, the mean for 500 is 0.50 added together 500 times, which gives me an answer of 250. That's 500 right there. So what is the standard deviation for 500 games? Well, it's the square root of 15.80 squared plus 15.80 squared, and I need 500 of them. So it's the square root of 500 times 15.80 squared, which is $353. $3.30. For example number 3, once again we're assuming that this is all standard deviation or all independent. So if I have a mean of 519 and a standard deviation of 115 and a mean of 507 and a standard deviation of 111, when I get the mean of the total, I just have to add these two numbers, which is easy enough. For the standard deviation, I'm going to square root 111 squared plus 115 squared. Actually, I probably should have put 115 squared first, but that's okay. So the square root of 111 squared plus 115 squared is 159.83. And one more here with a normal distribution. Bob has a mean of 110 and a standard deviation for Bob is 10. Tom has a mean of 100 and the standard deviation for Tom is 8. And so the mean of, let's see, Bob minus Tom is 10, and the standard deviation of Bob minus Tom is the square root of 10 squared plus 8 squared. Which is 12.81. So since this is normally distributed, they both are. My mean is 10 and my standard deviation is 12.81. So in this, we're trying to figure out that Bob scores lower than Tom. So normally Bob scores higher than Tom. So over here is 0. And so I'm looking for where Bob minus Tom is negative. So I'm looking for anything lower than 0 because a 0 is the top. So normal CDF, because I'm looking for a percentage, from negative 99999 to 0 with a mean of 10 and a standard deviation of 12.81. Gives me an answer of 0.217. And please send me any questions.